Hi, welcome to our first video for the Sec 5 math course. We've already spoken in class about one of the fundamental beginning points of mathematics, numbers, and we'd like to continue this time to expand into a discussion about algebra by talking about variables, expressions, equations, and so on. So first of all, a variable is a symbol that represents a quantity. We want to be very careful to precisely define exactly what our symbol is representing. And if necessary, we'll also use units. So let's say I'm thinking about solving a problem, and there's a certain quantity, the length of the side of a rectangle, that I would really like to know. Now, this should ultimately be the answer to the question. And so let's define a variable to represent that unknown quantity. So we'd say let L, for instance, be the length of a side of the rectangle. Now, of course, for a rectangle, we have several different sides, so maybe I should also include a little picture. Maybe this is the side I want to call L. And I'd also like to have some units here, of course. What are we talking about? Are we talking about in inches, in feet, in meters? If we don't specify, then really the reader doesn't know. So let's say in meters. So that statement of the definition of the variable should be a nice English sentence. Take your time to build it properly, and if appropriate, put some units. Make sure, too, that you are very intentionally specifying what quantity is being talked about. So we'd never want to say, let L be the side of a rectangle. A side isn't really a quantity. A side is just an idea. But the length of a side, well, that's a quantity. So we want to be as precise as possible and make sure we're talking about a quantity. We might say, let H be the height of the clown. And maybe this time we'll say in feet. Okay, so of course that's talking about some completely different problem. I don't think the rectangle and the clown are related, but here again we have specified that the symbol H is now going to represent the unknown quantity, which is the height of the clown, and our units are feet. Now, hopefully this is an important and relevant part of whatever problem we're trying to solve at the moment. We don't want to just define variables to represent unknown quantities that are irrelevant for the problem or won't immediately help us in our solving of the problem. Okay? And we'll talk more about that when we actually do some word problems and problem solving together. So a variable, again, it's just a symbol that represents a quantity. We want to be precise when we define it, and we want to specify units whenever applicable. Now, we can put together our numbers, real numbers, integers, our irrational, our rational numbers, whatever type of numbers we have, along with our variables, and we can connect them with operators. Operators are things like multiplication signs, or square root signs, or powers, or logarithms, things like that. Okay? They're different symbols that have specific mathematical meaning. So an expression is a collection of these numbers, variables, operators that are arranged in a mathematically sensible manner. So we might have an expression like, I don't know, 3x squared minus 5 times the square root of x. That's an expression. Okay? Another expression might be 2xy plus 5h minus 13q squared. Okay? All of these are expressions. Notice there's no equal signs here necessarily. These are just collections of these numbers, variables, and operators. In an equation, they might go on one side of the equation, but they aren't equations themselves. Those are expressions. Now, an equation is when we've got two different expressions, and we're actually saying something about them. We're making a statement that they're equal to each other. And usually that's in some circumstance. Within this word problem, these two different expressions, although they look completely different, are in fact representing the same quantity. Their values are equal to each other. And that's where we get equations from. So we might have one expression like 3x minus 7. We might have another expression like 4x squared plus 19. And then in the context of a certain problem, we might say, look, those two expressions are actually representing the same quantity, therefore they must be equal. So that's an equation. We have two different expressions, one on the left, one on the right, and then we're saying something very important. We're saying that they are equal to each other. So there we've got an equation. So why don't you try and write down your own equation right now. Make it pretty simple. And we'll go on and we'll talk a little bit about solutions to equations. So of course, usually when we write down an equation, we would like to know what is the value that I can put in for my variable that will satisfy that equation. That means that when I plug it in on the left-hand side and calculate, I get a certain number. When I plug the same value in on the right-hand side and calculate, I get a certain number. And those left-hand side and right-hand side numbers are the same. Whenever that happens, we're super happy. We have a solution to the equation. So here we're assigning values to the variables. And when we calculate each side, each expression separately, we end up finding out that the values of those computed expressions are the same. So for instance, let's say we look and we talk about a new equation above. So we might have 5x minus 1 equals 2. Okay? So it turns out that if we plug in just the right value there, say 3/5 for x, that our left-hand side and our right-hand side would be identical. So let's try it out here. So if we think about it, on the left-hand side, we might have 5, well, we will have 5 times 3/5. So 5 times 3/5 is 3. And then minus 1, that gives us 2. So on the left-hand side, we've got exactly 2. On the right-hand side, of course, there's no x's at all. The right-hand side is simply 2. So our left and right-hand side are the same. We can be confident that x equals 3 is a solution. Now, I'll sometimes in class use this short form, SOLN. You can use it as well. Also, notice that I have a couple different equations up above. I should be a bit careful about that. So let's give a label to this equation. Let's call that equation 1. So x equals 3/5 is a solution to equation, again I'll write it in that short form, 1. Now, when we check and verify whether or not a certain value is in fact a solution to an equation, we want to be very careful about how we do that. There's a very formal way to do it. So let's take a look at that now. So let's say I have this nice equation here at the top of the page. We'd like to check various values. I don't know whether or not these values are solutions or not. Now, what I'll need to do is I'll need to plug each value into the left-hand side of the equation, and completely separately, I'll plug it into the right-hand side of the equation. Now, I'll use ls as a short form for the left-hand side of the equation. When I plug x equals -3 into the left-hand side of the equation, of course, be careful and use brackets. Whenever you replace x with -3, it should be -3 in brackets. We'll have -3 all squared minus 5 times -3 plus 3. Do a little bit of integer arithmetic. -3 squared is, of course, +9. And -5 times -3 is +15. I never think about subtraction, actually. I always think about adding the negative of something. So I don't think of this here as -5. Instead of I think of it as plus -5 times -3. So we've got here plus 15 plus 3. Now 9 plus 15 is 24. plus 3 is 27. So when we plug x equals negative 3 into the left-hand side of our equation, we get 27. Now let's see what we get when we plug x equals negative 3 into the right-hand side of the equation. We'll get 3 times negative 3 squared minus negative 3 minus 3. If we simplify that, negative 3 squared here is positive 9 times 3 is 27. Minus negative 3, we have plus 3, and then minus 3. And look at that, we get 27 again. So the left-hand side is equal to the right-hand side. That means that x equals negative 3 is a solution to that equation. So we'll write a little conclusion at the bottom of what we just found out. Since the left-hand side is equal to the right-hand side, that x value we plugged in, x equals negative 3, is a solution to the equation. Okay, so that's what it looks like when we try out a candidate as a solution for the equation. Now this is the formal way to present it. What I don't want to see, I do not want to see you saying that the left and right-hand side are equal. If we say that right at the beginning, then we're assuming that it's true. But at the beginning we didn't know that. We didn't discover it until we actually calculated and found that it was that both sides evaluated to the same total. So we have to be very careful not to say things that aren't true or we couldn't have known they were true at the time we wrote them down. So we have to be pretty careful about that. You'll see what I mean in this next example. So we're going to plug x equals 0 into both sides of our equation separately. I need to just peek up here again what our equation was. So here's my left-hand side. I'll plug in x equals 0. There we are. And we'll figure out what that evaluates to. Okay, lots of zeros here. Okay, we very easily see that the left-hand side evaluates to 3. I'll put a big wall right there, and we'll calculate the right-hand side separately, because I don't know that they're the same. So I shouldn't say they're the same. So here we plug 0 into the right-hand side. And what do we get? We get negative 3 this time. Skipping a few steps there. Now if we look at the left-hand side and the right-hand side, they are not the same. So our conclusion this time is that since the left-hand side is not equal to the right-hand side, we can conclude that x equals 0 is not a solution. All right? Now, again, if we had said the left-hand side and the right-hand side were equal to each other from the beginning, we would end up with the terrible line 3 equals negative 3, which everybody knows is not true. And if it were true, I would be out of a job and very unhappy. Okay, so please help me stay employed here. Please help math continue to exist. Do not say that the left-hand side and the right-hand side are the same when you don't know it for a fact. All right. So please pause the video at this moment and give the final candidate a check. Plug x equals 1 into the left-hand side and right-hand side of the equation separately and determine whether or not it is a solution. All right. So now that you know for sure, I think if we take a look back up, we can quickly see that if we plug x equals 1 on the left-hand side, we would get 1 minus 5 plus 3. So that would be negative 1 on the left-hand side. If we plug 1 into the right-hand side, we get 3 minus 1 minus 3. That would be negative 1 as well. So we have the left-hand side and the right-hand side both evaluating to negative 1. Therefore, x equals 1 is a solution.